Computer Science 330, lecture number 3, serial communication. Today is August 25th, right, 2020. Okay, let's go. We have this robot. Again, this will be using when we get back to offline education. And well, today's lecture will be about serial communication, okay? But first class updates. We're going to have a quiz on Thursday. It's going to be online. It'll be Blackboard based. You can take it at any time of the day. Okay, completely up to you. Everything open, but still has to be your individual work. You'll be timed. You'll have only 15 minutes. Everything which was mentioned in class can appear in the quiz. And so everything mentioned in class, in the videos I'm asking you to watch. Yeah, everything which was verbally said, which was mentioned in the slides, which was spelled out. Everything is a fair game. Okay. Notes. I want you to take notes while watching this video and a couple of more videos which I will ask you to watch in this lecture. And I want you to submit them, handwritten notes. Again, I want you to submit them by midnight today. Okay. Cool. Serial communication. So I'm going to provide you theoretical background, and then I'm going to explain. Well, no. I'm going to provide you only the theoretical background for kind of understanding how communication works in computer systems. And then I will want you to watch this video and this video to understand how UART works, and also watch you kind of like go through the slides. Take the notes while watching the videos, but you don't have to take notes while you read it through the slides because it's not that important. Okay, theoretical background for understanding how communication works in computers. Okay, so let's think about this. Let's say we have internet, right? So let's say we have a network of two computers. Let's say that's computer number 1, PC number 1, that's computer number 2, right? And they somehow need to communicate. Of course, nowadays we have Wi-Fi, but it'll be too difficult to explain that through Wi-Fi. Let's say we don't have Wi-Fi, let's say we have wire. We have wires. Just some kind of like a cable between two computers, right? And it has, I don't know, let's say like four wires. Let's say 4 wires. Okay. And now, so the question is, how can we make them communicate? So let's say there are 2 people or 2 computers. How can we make them talk to each other? Okay. So again, let's say, I don't know, I want to transfer some digital information. Let's say, I don't know, like again, in the simplest case, those are bits or bytes, right? Let's say I want to transfer like 1 byte of data from computer number 1 to computer number 2. And let's say that that'll be our number 1, that'll be our 2. Okay. So how's that gonna work? Is the question. And interesting actually if you ever thought about how it works on the simplistic level. Okay, so again, in order to for them to communicate, right, they will be communicating using digital signals, right? However, let's say here I have a message, right? Let's say it's I don't know. Let's say I'm trying to transfer 1 byte. Okay. Let's say it's 111 444. Yeah. So 4 ones, 4 zeros. Okay. So I have 4 ones, 4 zeros as an information that needs to be somehow translated and transferred over here, and then at the end I should have, like in the computer number 2, I should have exactly the same result. I should have 1111 4 ones, 4 zeros, right? And the question is how to make it happen if again this part is digital, but over here we have wires which have physical voltage, right? So we kind of have analog information there. So over here we have analog information, you have voltage, right? Because that's how the wire works, right? So you have like 2 wires. I don't know if you have the outlet, right? So one of them has like 0 voltage, kind of the ground, right? The other one has 120 like volts there, or 220, right? I think in Russia it's 220. Well, but it's like fluctuating, so it's not AC, not DC, but yeah. But anyway, so it's physical. It's a physical signal, physical voltage. It's analog, like it's not digital, right? So you can't really have like 1 volt, right? Unfortunately, because it's too low. It's very easy to kind of to to confuse it with 0 volts, unfortunately. Okay, so in the basic scenario, in order to transfer at least some kind of data, you need to have 2 wires, at least 2 wires. Okay, so there are 2 wires. One of them is usually marked like black, usually, right? And that usually means ground. Okay, what does ground mean? Ground means, I'm not sure if you took any electrical engineering classes, but ground means it's a reference signal. Okay, so that means it's 0, right? And whatever voltage you can find over here on this wire, it's going to be compared to the voltage on this wire. Okay, and this wire is kind of considered to be ground, considered to be 0, right? Technically, but it's possible that, for example, over here you have like, I don't know, 1 volt, and over here you have like 5 volts, right? So this wire gives you like 5 volts of voltage, this wire gives you 1 volt of voltage. And in that case, again, you kind of have to assume that whatever this gives you is 0, right? So this compared to this, if this guy is 0, right, that means the difference between these 2 guys is 4. That means kind of this second wire gives you 4 volts of voltage, not 5, right? Because the other one is assumed to be 0. So anyway, so you have like two wires, right? You kind of measure voltage on both of them, and you find the difference, right? So you deduct whatever this is, you deduct whatever this is, ground, from whatever this is. For example, I mean, ideally it should be 0, right? So it should be 5 minus 0, but in this case, let's say if something happened and the ground is not 0 volts anymore, it's 1 volt. In this case, you'll go 5 minus 1, so it's 4 volts. Okay. Cool, perfect. Okay, so again, let's say in order to transfer any signal, right, we already found that we need 2 wires. Okay, when both of those wires show you 0 voltage, right, in this case, it's considered that kind of the first computer is sending you zeros, right, all the zeros. If on this wire compared to this wire, you have something like 5 volts, usually, I mean, it really depends like on the logic, but let's say 5 volts, right? That means kind of he's sending you ones. Okay, so again, if you have the kind of like 0 volts on this wire compared to this wire, right? So there is no difference, like 1 and 1 or 0 and 0. In this case, 0 is being sent. If you have anything different from 0, most likely 5, that means 1 is being sent. Okay. So again, imagine the situation. I have this computer, like hold on. Imagine I have something like this. So imagine I have like 2 computers. That's one computer. That's second computer. Okay. I have 2 wires in between. One of them is ground. Okay, and the other one actually has the signal. So if again I'm okay, so if let's say I am number 1 and you number 2, right? And if I'm sending you some data, again, what you have to do, you have to measure voltage on both of these wires, okay? And if there is no difference in between them, that means I send you 0. If there is a difference, like if the difference between them is 5 volts approximately, that means I'm sending you 1, okay? Perfect. Hope it makes sense. Now the question becomes, okay, but how can I like send the data like, I don't know, 8 bits, right? So, like, now I just described you basically how I can transfer to you 1 bit, right? Either 0 or 1, right? So I either apply voltage to this wire or I don't. If I apply, that means I'm trying to transfer 1. If I don't, that means it's 0. I'm trying to transfer 0. Now, so again, the next question is, how can I transfer, let's say, 8 bits, okay? So one of the ways of doing that is to have 1 ground and 8 wires additional, which would transfer 1 bit each. Okay, so it's possible to have just a bunch of wires, like, and then in that case I'll transfer you like 8 bits at once. Okay, unfortunately, through the history of time, as the kind of computer technology evolves, that did not become very popular. That logic is called parallel connection. Unfortunately, it didn't become popular at all. Nobody's really using that. So instead, what they do, they do it in a serial way. So they're basically going to have like 1 wire for ground and the other wire for the signal. But I'm going to send you digits right? I'm going to send you bits one after another. Okay, so the idea is that I'm going to send you, let's say, well, first off, we have to kind of agree on something, right? So for example, we agree that, hey, I'm going to be sending you 1 bit for each second. Okay, so for example, if I'm sending you, I don't know, for half an hour, let's say for 1 minute, I'm pulling this voltage up, right, to 5 volts, and you just for a minute you receive like only once. That means you received how many? 60 bits, and each one of them is 1. Okay, does it make sense? So it's very important that you and we agree on the same rules. Otherwise, for example, I'm sending you like, I don't know, 1 for half an hour. How would you know how many ones did I send you? Maybe it's 1 only, right, for the entire 30 minutes. Maybe, I don't know, like 200,000 of them, right? So we have to agree on those rules. It's very important. Okay, another way of doing this, like kind of, we can either agree on on this timing, or we can add one more wire over here, and we can call it so-called clock. It's usually spelled this way, C-L-K, clock. Okay, so again, now we have 3 wires: ground, clock, and the signal. Okay, so the ground is always 0. That's what we compare the voltage to. Clock is going to have the following form. So clock is going to look this way. It's just going to be iterating from 0 to 1, from 1 to 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, all the time. All the time, okay? And that basically means that, like, if I'm sending you the ground, the signal, and the clock, right? That means that for every so-called rising edge of the clock, which means, so where's the rising edge? Hold on, right? Okay, so that's the rising edge. So when it goes from 0 to 1. Basically, I'm saying that, yeah, so I'm sending you again a ground, signal, and the clock. And that clock basically says that, hey, like number 2, can you please, whenever this clock goes from 0 to 1, right? Whenever that happens, I'm sending you a new bit. So for example, in that case, if what you see on your side is something like this, let's say, I don't know, let's say it's 0, 0, 0, and then goes, let's say, like 1, like this. Okay, so that means you received 0 here, 0 here, 1 here, 1 here, 1 here. That means you received 6 bits. Sorry, 5. 0, 0, 1, 1, 1, 1. Okay, 2 zeros, 3 ones. That's how it works. So again, yeah, so this approach, when I'm sending you the signal and the clock, that's called synchronous, because we synchronize the clocks. And now the approach I was talking about that before is called asynchronous. Whenever we agree on some kind of timing thing, right? So for example, every half a second. So like if we talk about realistic number, right, then it's going to be like microseconds, a couple of microseconds. So like every microsecond, I'm going to send you a new number, a new digit, a new bit. Okay, that's how it usually works. Yeah, and that's basically, yeah. So what do we have to do? For example, again, if I want to send 1 byte of data for ones, for zeros, right? If we do it asynchronously, right? So I'm not sending you the clock. I'm basically saying, hey, like number 2, I'm going to send you, and we need to agree on that before we try to kind of send any data to each other. I'm gonna say, hey, look, let me send you 1 byte of data, 1 microsecond each for each bit, right? And then I'm sending you something like, I don't know, tick, 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 something like this, right? And then you, every microsecond, you'll be checking the signal wire, right? And you, for example, okay, so that's 1, that's 2, that's where you check it, right? So that becomes 0, that becomes 1, that's let's say also 1, that's 0, also 0, and now that's 1, that's 1, that's 0, right? So it's already 0, 1, 1, 0, 0, 1, 1, 0. Okay, that's already 8 bits. Okay. Yeah, sorry. Hope it makes sense. That's kind of how it works in a very, very simple way. Okay, now, let's say I'm trying to send you a bit more complicated stuff than 1 byte of data only. Let's say, again, yeah, let's say, let's say we have more than 2 computers, right, on a network. So first off, I probably should send you, so I'm transmitting the signal, broadcasting the signal to all the computers. And first off, I'm going to say the IP address of a computer who should receive my message, and everybody else should ignore that, okay? Yeah, so I'm basically saying the first byte will be, let's say, the IP address of the computer. The second byte is going to be the purpose of my message. Let's say, I don't know, 7 zeros and 1 would be welcome, 8 zeros will be, I don't know, goodbye, something like this. And we have to agree on that, right? And then third byte would represent the message by itself, right? So like each character in ASCII is 1 byte, right? So then I'm going to send you, let's say, 256 bytes of data, and I want you to translate that to text. And then I'm going to send you some kind of like a farewell message, okay? So that sequence of messages is called the protocol. That thing when we basically agree on, hey, like I'm going to first send you, I don't know, like a welcome message, then first going to send you the IP of your IP, right, to make sure that you understand, you're the one who should be receiving this message. Then I'm going to send you the welcome, then I'm going to send you the data, and then I'm going to I don't know, send the last byte would be goodbye byte, for example. So that thing when we agree on the length and the purpose of each byte of each message is called a protocol. So for example, IP, Internet Protocol, like Wi-Fi has its own protocol, right? I don't know. So everything, any communication between any two parties digitally has its own protocol, right? So kind of like in real life, when you're talking to your boss, there is a protocol, right? How you should be talking to him, and there are certain expectations. Same thing with it's much stricter in real, like in with digital systems, right? So there is a protocol, there are expectations. For example, USB, there is a protocol in USB, right? So how exactly the data should be transferred from the flash drive to to your computer. Same thing for SSD. Well, it's also USB, right? Yeah, cool. And the reason why am I telling you all of this? There is a special system of translated data from your laptop, from your PC to the robot, right? And that protocol is what the next lecture, those videos will be talking about. It's called UART. UART, okay. Whew. I hope it makes sense. Yeah, cool. What I want you to do, I want you to watch these 2 videos. This is the first one. Over here, the guy will be talking about UART, and that's the protocol. That's the type of communication, right? Which is discussed, kind of which creates those rules and guidelines of communicating, like between the 2 parties. In our case, it's going to be our laptop, like your laptop, and the robot. Yeah, UART protocol. Yeah, so basically like parallel in, parallel out, status like TX, RX. TX stands for transmitting, RX stands for receiving, okay? And then you have like serial in, serial out. Yeah, so he's gonna talk about that. 8 bits, you see that. So like UART transfers data in bytes. Okay, and in this video, basically talking about the same thing in a bit different words.
My name is Fritz, and I'm going to be teaching you
also about UART. So again, UART is basically the protocol, is the style of communication between the parties. Basically, again, like we have 2 devices, right? One of the, you have a couple of wires. One of them is called the ground, right? So like, and you have a couple of pins, right? Like pin is the output on the device. So TX of one device is connected to RX's of the other device, which basically means when this guy is transmitting the data, this guy is receiving the data, and vice versa. When this guy is transmitting the data, this guy is receiving the data. And the ground, right? So we have 3 wires, right? TX, RX, and the ground, but we don't have clock. What does that mean? That means we need to, these 2 parties need to decide on how quickly the data will be transferred, right? Otherwise, we need to have a clock. And the speed of that transfer is actually this baud rate. So that's basically how many bits per second, right? So like 1200 bits per second, or like 38,000 bits per second, right? So again, like when you establish the connection, kind of device number 1 and device number 2 need to agree on the speed. That's called the baud rate. But anyway, yeah, so those guys explained it like really well. Okay, that's pretty much it. I'll see you guys on Thursday, right? Yeah, hope it makes sense. Please prepare that for what? For the quiz. We're gonna have you're gonna need this information for the quiz, right? Let me know if you have any questions. Send me an email. Bye bye.